Hi, my students. So you are getting this link because you have successfully completed your moon phases lesson for today. And I want you to check your work and deepen your understanding. So the first four questions came right from the song. The idea that the moon orbits the earth, that's what's causing moon phases. And then here's the deal. The moon does not make its own light. If someone ever asks you to go for a romantic walk in the moonlight, you need to run. They are not showing good science. There's no such thing as moonlight. So here's question two, right from the song. Moon phases are caused by sunlight reflecting off the moon at different angles. And then this moon phase thing takes about 30 days. Technically, it's more like 29 and a half because that's how long it takes for the moon to go around the Earth once. And honestly, when I did that, that was a little off. It actually has a tilted orbital path, more like this. So about once a month, we see the moon phases start over. Now, here's the thing that's weird. Half the moon is always lit. Now, when I say always lit, I'm not talking about eclipses. That's something that's going to be part of our lesson for tomorrow. But during normal moon phases, half is always lit. But only twice in a month does it look like a half moon, and then we call it a quarter. And so it's all about these angles of reflection. Now, I'm going to quickly go over the 5 diagrams, what you should have said, but then I'm going to show you the positions with the moon phase simulator from the end of the lesson. So you should have said new moon to the first diagram because the back half of the moon would be lit up. So from Earth, it would look dark. Now, the second one was a full moon. Notice that the front half would be lit up. And if you're wondering, the sun is big enough, it can shine past the Earth most of the time and illuminate the front half. When you're on a two-dimensional screen, what you don't see is that like tilted orbital path, but just know that the sun has the ability to shine past the Earth and illuminate the front half for a full moon. Now, question 3. Oh, I'm sorry, I misnumbered these. This should actually say questions 5, 6, 7, 8, and 9. But anyway, question 7 was the first and last quarter moons. You knew that because of the right angles of reflection. And then question number 8, the waxing and waning gibbous moons, that's what those would have been because of the obtuse angles of reflection. And then the waxing and waning crescent would be number 9 because of the acute angles of reflection. So what I want to go to now, though, is the moon phase simulator so I can do a better job of showing you what I mean by these angles of reflection. So I hope that you took some time to explore with this. When I click launch here, you'll notice that there is a person on Earth, and that is you. Like that's supposed to be the observer on Earth that's looking at the moon. And so you see, we get this spinning of the Earth because we spin once a day. So you can see daylight, nighttime, daylight, nighttime. So here's the moon, and I want you to notice something. Half of the moon is lit, but it's the back half. And so from Earth, this is a new moon. It looks dark to us, even on a clear night. Once a month or so in this new moon phase, you don't see it. Now, that was your first one, when the new moon phase. Now I'm going to go all the way here. This is a full moon. And so I think you can see what I mean now about the sun's ability to shine past the Earth and light up the front half. Excuse me, and light up the front half of the moon. That's a full moon. Now, our next ones were the quarter moons. So let me get to right angles. Okay, this one, we call it the last quarter. Sometimes you'll hear it called the third quarter. But if you're the observer on Earth, you know it's the last quarter because it's lit on the left. But do you see what I mean now by the right angle? This is what I was singing about and what you watched in that video. Now, I come over here, and this one is our first quarter because on Earth, the right half is lit up. So still, though, we have right angles. Now, here's where it gets weird. One time in about the 30-day cycle of the moon, there's a new moon, just that position. One time, there's a full moon. One time, there's a perfect first quarter. And by the way, do you see why they call it quarter? when it looks half, you're really seeing a quarter because there's 1, 2, 3, 4 sections. Okay, and then there's only one time that there's a last quarter, or sometimes called third quarter. But now here's where it gets weird. When I start to run this and just let it go on its own, which I think I can do. Let me move me. That was not a good spot for me. When I hit play here, and you'll start to watch, you notice that this is now a waxing crescent. Okay, and waxing just means the lip part that we see gets bigger every night. Okay, now when I pause it and we look at the angles of reflection, this is an acute angle. But the question I have for you is, does this just take one night? And the answer is no. It takes about a week to go from a new moon, and I'll speed it up a little bit, over here to that first quarter. So this was actually question number 9 that was asking you about the crescent moons. Now when I get this way and I push play, this is a waxing gibbous. Notice it's lit on the right and it's waxing because the lip part's getting bigger, a little bit bigger every night. And this would take a week. About 6 nights is probably a little better. And then only one night where it's a true full moon, although the last night of a waxing gibbous and the first night of a waning gibbous actually look quite like that. Okay, but then here we have the waning gibbous, more than half lit, it appears, and it's an obtuse angle. Okay, so here it is again. The quarters are right angles, the crescents are acute angles, less than 90 degrees, and the gibbous moons are obtuse angles, more than 90 degrees. It's all about the angle of reflection.